Morning, everybody. Morning. How are we doing? We okay? Yeah. Okay, it's Friday, isn't it? Job a knock after this, is it? Yeah? Okay. Well, as Anthony said, my name's Dave. I'm a consultant engineer, and we get involved quite a lot within businesses from very large blue chip right the way through to quite small organisations, and we look at the way they're managing their electrical risks, and what we find is that there's a lot of misconceptions out there and there's a lot of misunderstandings out there. So what I want to do this morning is I want to really look at, first of all, what the law's telling us we've got to do with regards to electrical risk management, and also how you can actually go about compliance. That's what I want to talk to you about this morning. But I suppose before we go any further, I think what we really need to understand and just sort of refamiliarise ourselves with is why we need to go through this process. Why do we care about electrical risk management? Well, we care because the stuff's dangerous, isn't it? It's as simple as that. And if we're working in and around electrical systems, or we've got people working around electrical systems, the main risk that we're up against, or they're up against, is the risk of electric shock, isn't it? Who's had electric shock? Yeah, okay. Anyone enjoy it? Oh, hey, there we go. Hey, listen, people go to Amsterdam and pay for stuff like this. I don't know, you might be like that. But quite a few have had electric shocks, so you know what it's like. You come into contact with a live part, every muscle in your body contracts, you get that extreme pain going through your body. The good news is, though, it doesn't last very long, does it? Because very, very quickly, your heart goes into ventricular fibrillation, you drop down the floor, brown bread, it's all over. Now, this might sound like quite a bizarre statement to make, but those of us who do accident investigation work will always tell you this. If you suffer a severe, the key word is severe, electric shock, and you die straight away from it, you've actually got away with it lightly. Because the worst cases of people suffering severe electric shocks that we come across are where they also suffer severe electrical burns. You can get two types of electrical burns. First of all, you can get the external burns. I don't know, you might have seen pictures of this, where you get that really nice outside crispiness of the skin, where literally the outer layers of the skin have burnt off one by one, going down towards the bone. Second, third degree burns. Very, very painful, very lengthy rehabilitation periods. You will be horrendously scarred for life. End of. But arguably, as nice as that all sounds, the worst types of burns that we can get are actually the internal burns. And if you think about it, folks, the human body is roughly made up of around 80% fluids, blood, water. I don't know, give me about 10 o'clock tonight, I'll have a few cans of Stella in there as well. But the point is, if you come into contact with a live part, you complete that circuit and the current goes through you, what's going to happen to that fluid, folks? Come on, what's going to happen to it? It's going to boil, literally. It's going to get very hot, it's going to boil, and it's going to start cooking up your internal organs. It's no different from having a big Chinese hot pot where all the meats are bubbling away inside it. And that's why you might hear the people having a bad electric shock and dying maybe 3, 4, 5 days later. It's because their internal organs have been that badly damaged that they're breaking up and giving up the ghost one by one. Real pleasant way to go. Now, believe it or not, when we started bringing all this legislation out in the UK with regards to electricity and working in and around electricity, we weren't just worried about us lot, about people, about employees. What we were also doing as an industry, as a nation, if you like, we were also listening to the insurance companies, because they were sick of paying for buildings to be refurbished or rebuilt because they were suffering fires due to unsafe electrical installations. So there's a number of risks here. First of all, overload. Too much current goes through something than what it's designed to cope with. Sooner or later, it's going to cause a fire. End of story. This next one here, folks, leakage currents. Don't underestimate how big a challenge we've got in the modern built environments with leakage current issues. For those of you who might not be aware, leakage currents are where we get naturally, because of the design and the makeup of pieces of equipment, and by the way, this is many types of equipment that we now connect to electrical systems. Naturally, what we get is we get currents on the protective conductor, on the earth conductor. Well, clearly that doesn't sound very good, does it? But it's something that is a natural phenomenon now, and what we've got to be able to do is identify it and protect against it. Poor insulation around conductors is going to cause a fire sooner or later. And then this other one here, folks, this is something we're really, really good at in the UK, because what we do in the UK is we get things like distribution boards and fuse boxes, and 9 out of 10 times, folks, where do we usually put that type of equipment? Go on, dish boards, fuse boxes, where do we usually put that type of kit? Cupboards, that's exactly where we put them. Now, we're quite clever. We know that this type of equipment can create sparks in certain circumstances. So knowing that, what do we also put in these cupboards, folks, with this equipment that can create sparks? Yeah, we put cleaner stuff, don't we? We put bog rolls and flammable chemicals and coats. For God's sake, we even put gas meters in these cupboards as well, don't we? Which kind of leads us on to these items that we've got at the bottom, is the risk of explosion, but we'll get into that in a bit more detail later on. Okay, so in the UK, clearly when we're talking about electrical risks, electrical risk management, the main piece of legislation that we're interested in is this one that's here on the screen, Electricity at Work Regs 1989. I'm sure you've all heard of it before, you've all come across it before. And if it's got an ethos or a mission statement to it, it's this statement here in blue, that it requires precautions to be taken against the risk of death or personal injury from electricity and work activities. Well, you see, when we look at that, folks, what a really obvious thing that is to say, isn't it? We don't want people getting hurt or killed as a result of electricity in the workplace. Well, of course we don't. So I think before we go any further, I think what it's worth doing is just trying to really understand and appreciate why it is that we've got a piece of legislation here in the UK where such an obvious mission statement is the underpinning ethos to it. So let's have a quick history lesson. Let's go back to the turn of the last century. Turn of the last century, Industrial Revolution's well and truly kicked off. We've got factories and workplaces all over the country, haven't we? Now, clearly what that means is we've got people employing other people to do a job of work for them. But the big problem we've got is that we've got no legislation in place that makes these employers keep their employees safe. So what's happening, folks? People are dying, they're getting injured, there's fires, there's all kinds of stuff going on. Now, something else to appreciate before we go any further. In the UK, what we are is we're a reactive nation. In the UK, what we do is we wait until something goes wrong, and then we investigate it, then we say something's got to be done to stop it happening again. It's all back to front, isn't it? And that's basically what happened at the turn of the last century. People are getting hurt and killed, there's all kinds of stuff going on, something's got to be done about it. So what we did is we brought in a series of acts called the Factories Acts. Heard of them before? Yeah. Massive step in the right direction, but in relation to what we're talking about this morning, there were no real specific requirements in there to make us have safe electrical installations or to make us employ safe electrical working practices. So we then move forward a little bit. We get to 1974, Health and Safety at Work, etc. That comes out. It's got more bells and whistles on it, sings and dances a bit more, but the same problem. Nothing in there really makes us focus on electrical risk. So we then get to the early 1980s. By this stage, we're into statistics. We start looking at the statistics, and what we realise is that we're killing somewhere in the region of between 90 and 100 people every year in the workplace as a direct result of electricity. So we stamped and screamed about it. Something's got to be done. Bang, in comes this piece of legislation. So it comes into full force, or it came into full force on the 1st of April 1989. Now, when we're talking about a piece of legislation, you may be forgiven for thinking that all of the regulations that are contained within here, you've absolutely got to comply with. And the reason you may be forgiven for thinking that is because that's not actually necessarily the case. And the reason it's not necessarily the case is because the regulations that are contained within here are given one of two status. So the first status that can be applied to these regulations is what we call reasonably practicable. Now, have you all heard that statement before? Yeah, of course you have. So let me ask you this then. What are we asking if we say, is something reasonably practicable? What's the question? What's the factors that are going into helping us answer that question, do you think? Anyone? Cost. Ooh, that's quite an important one, isn't it? Cost. So what else do you think we're also looking at? What other factors are in this mix?
Time.
Say again?
Time that it takes to do it.
Absolutely, yeah. Anything else?
Risk. Risk.
Yeah, absolutely, risk. So in effect, it's a balancing act, isn't it? On the one hand, we're looking at the safety improvements we're going to make, and on the other hand, we're looking at the time and the cost implications. So to put it simply, if we spend £1 million to make a tiny safety improvement, we haven't got the balancing act, therefore it is not reasonably practicable. Now, the second status that can be applied to these regulations is what we call absolute. It's exactly what it says on the tin. You absolutely have got to comply with what that regulation's telling you. No ifs, buts and maybes. And I'll give you a couple of example excuses that we hear very, very frequently, and I bet you most of you will have heard these. Oh, you can't shut down the comms room because that means we won't be able to access our data, and that means we're going to lose money. You heard that one before, have you? Yeah, of course you'd have. And I'll tell you the other one we hear quite a lot. Oh, you can't shut down the production line because we'll lose X thousands of pounds a minute if you do. Oh, and by the way, a good production manager will know to the penny how much they're going to lose if you shut it down. But absolute requirements mean that time and cost don't come into it, so you can't take them into account. So those types of excuses for absolute status regulations, no, doesn't apply. Now, talking of apply, what we've got to ask ourselves now is exactly what is it that this legislation applies to. Now, if we had a copy of this in front of us, we go to the first page, we're going to see there's a scope. And the scope of this document, says that it applies to electrical systems. Now that sounds like quite a broad brush statement, that, doesn't it, folks? So again, let me ask you another question. See, make sure you're all awake this morning. What do you think something's got to have that qualifies it as being part of an electrical system?
Electricity.
Yeah. Now, that's an absolutely correct answer. But again, that's quite a general term, isn't it? So if we want to make that more specific and define it a little bit more, as correct as it is, what would we say is going through something?
Current.
Say again?
Current.
Currents, absolutely. And what else could it be, folks? Could be current, and it could also be? Yeah. So firstly, word for word, that's what the scope of this legislation says. If something has a voltage and or a current going through it, it forms part of an electrical system. Now, if you think about that for a quick second, folks, that's a massively wide range of equipment we're now saying comes under the requirements of this legislation. So on the one hand, we've got 400,000 volts overhead power lines. We come through the scale to single three-phase power and lighting systems. I'm guessing most of you are probably either playing with every day or you certainly got responsibility for. And then we go to the other end of the scale where we're looking at something as seemingly innocuous as a little battery. So here's another question for you. If I've got a rectangular 9-volt battery here, is that dangerous? Can be. Okay, let's have a quick tangent. I like daft people. I'm a daft person. So let's see how many dafties are in the room this morning. When you were kids, did you ever get a 9-volt battery? Put it on your tongue. Yeah? Quite a few of us? Okay, good. I've got dafties in the room. I like that. Now, back to the point I'm trying to make. The thing is, we're here to tell the tale. Those of us who were daft enough to do that, we're here to tell the tale, aren't we? So what we can pretty much categorically say is that the 9 volts from that battery isn't capable of killing us. But what we've got to consider is this. Let's say that our 9-volt battery is in a potentially explosive atmosphere where we've got combustible liquids, gases or dusts. What can the battery do, folks? It can create a spark which can ignite the atmosphere, and that's why something as seemingly innocuous as that battery still comes under these requirements here. Okay. So what I want to do is I want to look at and focus on one of the regulations from this document with you, Regulation 3. And this particular regulation talks about persons on whom duties are imposed. And I suppose one of the traps that we can sometimes fall into, certainly as employees, is to say, well, hang on, it's not my responsibility for our safety, it's our managers, directors, shareholders. It's their responsibility to keep us safe. Now listen, before we go any further, if they're making money off the back of what we do for them, damn right they should have legal responsibilities for our safety. That's why we needed the Factories Acts in the first place. So what we're used to seeing employers, directors specifically named in health and safety legislation and given responsibilities for our safety. But what we now see, certainly when we look at Regulation 3 of Electricity at Work regs, we see sole traders specifically named. Training providers are in there. And what we've also got, ladies and gents, is this little statement here in blue. Word for word, Regulation 3 says that employees, which is probably most of us lot in the room, I'm guessing, have a duty of care under works for which you have a direct control. Okay? And to put it another way, if you're a manager with responsibility for the maintenance and the upkeep of the electrical installation or the electrical system, that statement applies to you. If you work on electrical systems day in, day out, that statement applies to you. And it can be as simple, by the way, as walking up to a panel on the wall, opening the lid of that panel, and if by doing so, you are creating access to potentially live parts, in the eyes of the law, you are now deemed to be working on an electrical system. It's that simple, okay? So the minute you start working on an electrical system like that, the minute you have responsibility, you get issued a job description and you start employment as somebody who has the responsibility for the maintenance of electrical systems, the law attaches a little piece of terminology to describe what you've now become. And that terminology, ladies and gents, is that you're now a duty holder because you have a duty occur to yourself and those who can be affected by your actions. Now, when we're looking at reasons, for want of a better phrase, why we've got to maintain electrical systems under our control, we're not just looking at Electricity at Work regs because this is backed up in other parts of legislation. And when we look at PUE, Provision and Use of Work Equipment Regulations, again, I'm sure this is a document most of you will be more than familiar with. Again, what it's doing is it's emphasising, and we're particularly narrowing this down to the actual equipment that's connected to our electrical systems now, but what it's basically saying is that we've got to make sure that this equipment is suitably maintained, that it's fit for its purpose, that it's able to be kept in continued use. I'm not going to read it to you and everything. You can get the gist of what it's asking for, but it's another piece of legislation that's reinforcing this requirement to maintain equipment, electrical systems. Funnily enough, that's not it, because we've got another piece of legislation that does virtually exactly the same thing, the Workplace Health, Safety and Welfare Regs. Again, what you can clearly see there is it's talking about this necessity to maintain. It's using words efficient state, efficient working order, good repair. So it's constantly, in different pieces of legislation, it's reinforcing this requirement that we've got. Now, sadly, having all this legislation in place doesn't automatically mean that people are going to comply with it. Anthony spoke to you briefly before about those that don't care. And sadly, there's a lot of the people that don't care in the UK. They've got a rough idea what the law's telling them, but I'm not bothered. It doesn't apply to me. So sadly, when you've got legislation, because you've got people like that, what you've got to make sure is that you've got incentives to make sure that people with these legal responsibilities are complying. And what we've got with this particular, killed it, there we go. What we've got with this particular document here, Health and Safety Offences Act 2008, is a document that was brought out to really increase and make sure we've got incentives to comply with legislation. And basically, this was specifically brought out because it amended Section 33 of the Health and Safety at Work, etc. Act. Section 33 is the little bit that enables courts, etc., to be able to issue penalties, fines, things like that. And what this was done, this was brought out to add a new Schedule 3A to that document with increased powers. Now, let me just read these out to you so I don't get them wrong. Lower courts, as a result of this, will be able to resolve more cases quicker. Fines of up to £20,000 for the majority of health and safety offences can be issued in lower courts. Unlimited fines can now be issued in higher courts. And imprisonment up to 12 months can be issued in a magistrate, up to 2 years in Crown courts. Okay, so there's your incentives. If you're responsible for this type of maintenance activities, whatever it may be, there's some incentives for you, because that's specifically targeting the likes of yourselves, if that's the case. And what we've also got this document here, Corporate Manslaughter, Corporate Homicide Act. Now, it looks, when you see these two words, we're basically saying the same thing twice, aren't we? So the question is, well, why are we saying the same thing twice? Well, the reason is because depending on where you are in the UK, depends on which one of these or which broken down bit actually applies to you. If you're in England, Wales, and Northern Ireland, it's called the Corporate Manslaughter Act. If you're in Scotland, it's the Corporate Homicide Act. But the reason this document was brought out was to take into account basically for the fact that what we had was a lot of people in businesses going, well, that's not me, it's them, it's her, it's him. And it was passing around. There was no real accountability for exactly who should have been making sure these things were happening. So the reason this document was brought out was to start being able to put fines and penalties on actual legal entities, on organisations. And when we talk about the types of organisations, we'll look at that in a second, but that's what this was brought in to do. Where are you going to hit a company the most, ladies and gents? Profits? Yeah. That's where you're going to hit a company the most. If there's a good way of convincing a shareholder that it needs to be complying with law, what you need to be doing is telling them that we're going to be fining you and that money's going to come directly off your bottom line. That's how you convince a company to make sure that they're doing something. In addition to that, ladies and gents, have you all heard of the Crown immunity before? You ever heard of that phrase, have you? Crown immunity? Some have, some haven't. Crown immunity was basically something that was in place quite a long time ago, historically. And what it basically meant was that governments, public sector organisations, anything that was funded ultimately by us, by the people, was immune and didn't have to bother with complying with all this health and safety legislation. So if you were a prison, if you were a school, if you were a hospital, didn't apply to you because you're a government organisation. So we didn't have to comply with all of this. Now, bit by bit, thankfully, over the years, Crown immunity has been gradually taken away. And the other reason this document was brought out, this piece of legislation, was to further remove Crown immunity. So when we look at the types of organisations, I'll just get out your way so you can all see that. The types of organisations that this Act is specifically targeting: Crown bodies, armed forces, police forces, partnerships, incorporated companies, trade unions, there are a few more, limited liability partnerships, limited companies, NHS trusts, local authorities. As you can see, we're basically capturing everything there, aren't we? No one's going to get away with this, for want of a better phrase, now. So there's your incentives. Whether you're a business or whether you're an individual, there's your incentives, isn't it? So, let's come back to electricity at work regs. When we look at Regulation 4 electricity at work regs, it talks about systems, work activities and protective equipment. And there's two real main parts to this Regulation 4. Regulation 4.1 clearly says that all systems shall at all times be constructed as to prevent danger as far as is reasonably practicable. Reg 4.2, as necessary to prevent danger, all systems shall be maintained, again, as far as is reasonably practicable. And then what we've got here, we've got this statement. The obligation to maintain arises if danger would otherwise result. Well, we're talking about electrical systems here. If we don't maintain them, danger is going to result. It's an absolute fact. So that's why that statement's there, is to really reinforce this. So basically what we're saying here is we've got to construct our installations properly, and then we've got to make sure that they're suitably maintained. So the question then is, well, what requirements are there? What fundamental requirements are there for us to make sure that our installations are properly constructed and then to make sure that they're properly maintained? Well, that's why I want to go through these regulations here. What have I got? 7? 1, 2, 3, 4, 5, 6, 7. 7 regulations. And what these are, and the reason I want to go through these with you is just to really give you an understanding and a flavour, first of all, what the fundamental requirements are for electrical systems, but also just to really emphasise why it is that we needed legislation here in the UK, in this case, to make us have safe electrical installations. So, the first regulation there, Regulation 5, talks about the strength and capability of electrical equipment. And basically what Regulation 5 wants us to do is identify any piece of equipment, doesn't matter what it is. It could be a bit of cable, it could be a switch, it could be a light fitting, it could be a distribution board, an isolator, anything, okay? And what that regulation wants us to do is look at that bit of equipment, and it wants us to make sure that it's capable of coping with the voltages, the operating currents, and the prospective fault currents that are likely to go through it, okay? So, as an example, most of you probably will have seen something like this before. On the wall, we've got an isolator. It's a 100 amp isolator. And our 100 amp isolator is controlling, let's say, a motor. What's going to happen, ladies and gents, to that isolator if the motor pulls, say, 130 amp? What do you think is going to happen to it? Oh? Nope. It's not a protected device, is it? It's an isolator, don't forget. It's just going to get warm, isn't it? Okay. We go up to it, we touch the side, we're going to feel a warmth there. Now, what's going to happen to our 100 amp isolator if the motor's pulling, say, 250, 300 amp? It's going to get very, very, very warm, isn't it? Yeah. It's going to get very, very warm to the point where it's actually going to set on fire, and it's probably going to take building fabric around it as well, isn't it? Now, somewhere in the middle of our isolator getting a little bit warm and the bloody thing going on fire is actually the most common occurrence that we get in this set of circumstances. And if you think about it, in our isolator, we've got two metal contacts touching each other. They're now getting hot due to the fact that there's electrical current going through them. What condition's going to occur there, gents and ladies, I should say? It's going to weld, isn't it? What's the last thing you want an isolator to do? Weld together so you can't turn the damn thing off. Exactly, and that's where Reg 5's coming from. Right, your next one. Your next one, Reg 6, talks about adverse or hazardous environments. There's two aspects to this, folks. First of all, we've looked at this one briefly already, where we're looking at hazardous environments, potentially explosive atmospheres, where we've got combustible liquids, gases or dusts. And what Regulation 6 wants us to do is it wants us to identify any electrical equipment that can create a spark, and it then wants us to enclose that equipment, and this is where we get EX-type equipment from, that prevents the spark igniting the outside atmosphere. The second element to Regulation 6 is looking at any environmental conditions that can cause an adverse, detrimental effect to the electrical installation. So, what environmental conditions can you think of that can cause deterioration of an electrical installation?
Humidity, condensation.
Yeah. Well, let's focus on that, because that's water really, isn't it? So the different levels are, as you said, humidity, but we could have rain, we could have submersion or immersion, couldn't we? So there's different levels of that one, isn't there? What else have we got, folks? Say again? Absolutely, yeah, because we get UV rays from the sun, don't we? UV rays damage electrical systems. What else? Temperature. Yeah, and there's two levels of that, isn't there? Extreme cold, extreme heat. What else can you think of?
Dust and particles.
Yeah, that's it. Dust. Anything else? Go on, give me a chance to get some water down me.
Bird muck.
Bird muck, yes. Bird muck, very corrosive. So to put it another way, corrosive or polluting substances, but yeah. Anything else? Could have flora, we could have fauna, we could have the movement of buildings, quite a few things here. Nevertheless, the bottom line is, what Reg 6 wants us to do is identify these environmental conditions, and we've then got to design and construct our electrical installations so they don't suffer as a result. Now, let me introduce you to the most obvious sounding regulation you're ever going to hear in your life. Regulation 7 talks about insulation and placing of conductors. And we could basically reword that to say, thou shalt not be able to touch a live part. That's exactly what that regulation means. So in other words, what that regulation wants, if we've got a copper or an aluminium conductor, Reg 7 wants it surrounded by the PVC or XLP insulation so we can't touch it and get a belt off it, obviously. Likewise, if we've got buzz bars, Reg 7 wants our buzz bars inside something like a buzz bar chamber or distribution board, some kind of enclosure again, so it stops us getting access to them and getting a belt from them. Another really obvious regulation for you is Regulation 8. Talks about a requirement for earthing systems to be in place. So we've got earth paths so that any fault currents in our electrical systems are going to go down to the general mass of earth, they're going to be neutralised, they're going to be made safe in effect. Reg 10 talks about connections. And what Reg 10 wants us to do is identify any type of connection within an electrical system. Doesn't matter what it is. It could be a cable going into a terminal, it could be a conduit going onto a trunk, and it could be a gland going into an enclosure. Regardless of the type of the connection, Reg 10 wants us to ask 2 questions of that connection. Both of them questions have got to have a yes answer. So the first one, is the connection mechanically sound? So again, you think about the cable in the terminal. If it isn't mechanically sound, we give it a tug, it comes out, it's neither use nor ornaments. The second question, ladies and gents, is the connection electrically sound? So again, you think about the cable in the terminal, if it isn't a good solid connection, we're going to get an increase in resistance on the circuit, we're going to get sparking and arcing, and in the worst case scenario, that's going to cause a fire, isn't it? Regulation 11 talks about having a means of protecting from excess of current. So we're looking at protecting against overcurrents, protecting against fault currents here. So this is where we get our requirements for fuses, for miniature circuit breakers, moulded case circuit breakers, circuit breakers, etc., i.e. some kind of protected device that's going to activate in the case of fault conditions. And last but not least, Regulation 12 talks about having a means for cutting off the supply and for isolation. So there's 2 bits to this. First of all, we talk about cutting off the supply to something. What we're very simply saying is that we've got to have the means to be able to switch it off, okay? The second part is talking about isolation. Now, the term isolation has a definition, which is this, that it can be switched off, an inadvertent reconnection prevented to enable compliance with Regulation 13, which is precautions to work on equipment made dead. Now, I know that's a bit of a mouthful, but basically what we're saying, folks, is that we've got to be able to switch the supply off to something, and then we've got to be able to prevent it coming back on until we want it to come back on. They are basically your fundamental key requirements for electrical installations, electrical systems. So, that's quite a lot about the law and what the law's saying and what the law's requiring. So the question then becomes, well, what do you do about it? So you might be a duty holder, you might have responsibility for the maintenance of electrical systems, and something we come across very, very often is this particular one at the bottom here. People who are worried and concerned about being able to shut down their electrical systems to carry out this essential maintenance to make sure that they're complying with all these requirements that we've been looking at. So, before we start looking and breaking that down, what we've got to do is, as an organisation, any organisation anywhere, the first thing you've got to do before you just go wading in and doing pat testing or doing fixed wire testing or whatever it is, you've got to establish the magnitude of the risk that you've got. The way we establish the risk is looking at things like this that's on the screen. So we look at what PPM programs have we got in place. I'll go back to what I said before. In the UK, we're a reactive nation. So what we generally do is we start looking at incident reports. If something's happened, well, what can we learn about from that? Pat testing, fixed wire testing, but it all comes down to this, establishing the magnitude of the risk. Now, dare I say it, there are 2 ways in which organisations go about doing this. And this is what we very typically come across when we're working with organisations. And as with everything, by the way, there is a professional way of doing it, a proper way of doing it, And then there's the let's lick our finger and stick it in the air and see which way the wind's going, way of doing it. What I want to talk to you about first is the professional way of going about it, to really sort of hopefully make you understand all of the factors that you've got to be considering when you're looking at electrical risk management and you're taking an approach towards it. So your professional methodology, folks, is utilising this code of practice here. Code of practice produced by the IET, specifically for electrical safety management. What this code of practice does is it allows you to manage the risks associated with your system by the use of a self-assessment tool. And in effect what it's doing is it's allowing you to score the current magnitude, the current level of your risk with regards to electrical safety, clearly so you can target improvements and then revisit that self-assessment tool at a later date and see where you're up to with it. There are 4 main areas of assessment that this document breaks down. So let's go through them as quick as we can. First of all, you're looking at managing policy aspects. Okay, so first of all, is there a policy? Is it adequate? Is it approved by top management? And is it frequently reviewed? We're not talking about a health and safety policy here. We're talking about an electrical safety policy. Okay? Does top management lead on electrical safety matters? Is the consultation with employees? Do management only react in the case of an incident? Sadly, in a lot of cases, that's what happens, isn't it? And also, sadly, very often, management teams are unlikely to consult and engage with the staff that are actually carrying out the activities. And clearly the best people to speak to when you're looking at putting systems, policies and procedures in place are the people actually doing the job on the coalface. Is there a plan to identify electrical safety issues, or are they only identified as and when activities are carried out? Again, that's sadly quite often the case. Do we actually measure electrical safety performance? Is design undertaken in accordance with appropriate standards and by competent people? Now, let me get another misconception out the way for you this morning. The vast majority of electrical installation design work in the UK isn't carried out by chartered engineers. It's not carried out by incorporated engineers. Okay? Very often, the design work is actually carried out by the electrician that's about to do the work. And what they'll do is they'll stand there and they'll go, yeah, okay, we're going to run a 6 mil in, we'll put it here, we'll clip it down there, we'll do this with it, we'll put a 32 amp breaker on it. That's how most design work in the UK is done. Okay? Now, I'm not saying that's wrong. That's fine for certain levels of electrical installation work. But clearly, once you start getting into more complicated electrical installation work, there needs to be much more thought put into it. It needs to be documented. Engineering decisions need to be documented and drafted, etc., etc. Does the electrical installation meet the requirements of recognised standards? Now, again, excuse the pun, you would be shocked how many times we do design verification work where we look at design work that's been carried out by very well-known, very large design houses up and down the UK. And they've had very highly qualified people carrying out this design work. Yet when we do the verification of that design, what we find is there are many, many non-compliances with BS 767 on the wiring regulations. You'd be stunned how often that comes across, that crops up. What about fixed current using equipment and equipment connected by a plug and socket? Are we considering that? Next, we move on to managing procedure aspects. So, first and foremost, are risk assessments used and are control measures implemented? Now, let's get another elephant in the room identified. The vast majority of risk assessments that we see, and I bet you most of you will agree with this, they're generic. If we go on a job today, the risk assessment we're seeing for that activity is exactly the same risk assessment that we would have seen had we been on the job next week looking at the same activity. The only difference is there's a different date on it and a different client name and address. Tell me I'm wrong. Sadly, I'm not, am I? Safe working practices. Is the housekeeping inspections in place? Are switch rooms, distribution boards, control panels, do they have secured access on them? Are we preventing unauthorised access? Quite often we don't. Are we using appropriate tools and test equipment? Is that test equipment being checked, being calibrated, etc.? What about the tools? Are they being checked for their adequacy? What about precautions for working near electrical cables? What about safe access to equipment? The amount of times we go in installations where people are having to work at a distribution board and there's a gap like that between them and the wall. Clearly that's not safe working, is it? Workplace precautions. Have we identified suitable safety precautions and have we communicated them? So many businesses we go to have got fantastic systems, policies and procedures. They're all sitting on the service system. They haven't communicated them to anybody. They haven't passed it down, back down the chain to the people actually carrying out the activities. What about procedures for managing electrical work? Safe isolation procedures, do we have them? What about operation and maintenance of electrical equipment? You might have a qualified electrician or an engineer on your hands, but that doesn't mean that they're competent to work on a specific piece of equipment. They might need product training. They might need to have access to the O&M manuals for that equipment. What about planned maintenance, inspection and testing of the electrical system? Is it being carried out? Are there records for that? Do we have fixed equipment and equipment supplied by plug and socket? And again, if we do, we've got to make sure that we're inspecting and testing that and capturing that. Goes back to what we said earlier on, doesn't it? Documents. Here you go, this is a good one. Are there O&M manuals available? As fitted drawings, schematics, settings of protected devices, maintenance records, identification and labelling of equipment. The vast majority of installations we go to, that's not the case. We don't have those records on tap. I'm going to pick up on one of them in particular for you, settings of protected devices. For those of you who don't know, certain types of protected devices, specifically moulded case circuit breakers, have little dials on them. And the reason there's little dials on them is so that you can alter the protective level that that device gives you. Now, the amount of times you go to a site, there's no records for what the settings should be, and what somebody's done is they've just put them all to 12 o'clock because that makes it look nice and neat. That doesn't mean it's been set properly, okay? What about measurements? Are there electrical safety performance measures in place? Are they consistent with the electrical safety policy? So is there an ethos of continual improvement here? What else? What about the people aspects? Now, this is an important one. In fact, before we go any further, let me ask you the question. Who in the room has got responsibility for the maintenance of electrical systems under their control? Anybody? 1, 2, 3? Okay, that's quite a few of you, that, isn't it? Out of the ones who've just put your hands up, have you been issued with job descriptions? Who's been issued with job descriptions out of them lot? Yeah, one? One of you? Okay. In your job description, is there a specific item that says and details that you've got responsibility for the maintenance of electrical systems? Do we see the flaw there, folks? Until we've got something that clearly tells our employees what their exact responsibilities are, what their duties are, it's a little bit open, isn't it? See what I'm saying? So, let's start again. Appointment roles and responsibilities. Who's responsible for electrical safety? Is this documented? Are specific roles or tasks allocated to personnel? Are staff aware of their responsibilities for complying with the electrical safety policy? Well, until we communicate all this, until we issue job descriptions, we've not got that, have we? What about training? Has electrical safety awareness training been delivered? Most businesses, that's not the case. What about technical training? Has it been delivered? What about first aid training? And this moves us nicely onto this next one, this issue of competence. Now, competence is a very subjective term. And I don't mean it's subjective because your opinion of what the qualification level of electrician is this, that and that, and my opinion is something completely different. We don't mean that. What we mean is that competence is dependent upon the activities that are being carried out, isn't it? So as an example, if we've got a refrigeration engineer here, the likelihood is that that refrigeration engineer will never have gone through virtually any kind of electrical training, or little tiny units as part of the training, but they will probably not have electrical quals. Now, I've never worked on refrigeration systems, but I did work as a spark for quite a long time. Now, if you give me test equipment, drawings, and a good part of a day, it'll take me ages, but I'll probably find a fault on a refrigeration panel for you. If we've got a refrigeration engineer here, they'll probably find the fault like that, won't they? Why is that? Yeah, because they do the job every day. They're constantly doing the job, therefore they know what to look for and where to look for it. So something like that, refrigeration work, when we look at the electrical training and competence elements to it, their competence level may need to be electrical awareness training coupled with the years and years and years of experience that they've got of actually doing that job. But without sounding derogatory to people doing that, once we start talking about more complicated electrical working activities, clearly the competence level needs to increase. And it becomes in a number of parts, because don't be focused on, we've got to look for particular qualifications, because is the individual suitably qualified, is equally as important, and is the individual suitably experienced? And has the individual received appropriate internal or external training? So there's 3 elements to competence when we're talking about the majority of electrical work that needs to be carried out. Cooperation. Do managers and workforce develop electrical safety measures together? Are there regular safety operational meetings, health safety environment committee meetings, that type of thing? Engagements, do we have that? And then last but not least, audits. There's a very true adage here for you. What gets checked, gets done. Is that a fair point? If we're auditing something and identifying non-conformances with our internal systems, with legislation, etc., we need to go through the process of making sure that they're corrected, putting preventive actions in place, and then hopefully learning lessons and moving forward and developing our system by doing that. Last but not least, we look at managing specific issues. So, for example, are procedures in place? Do we have justifications for live working? And this all comes down to Regulation 14, by the way, another reg that we're not really looking at in detail this morning from Electricity at Work regs. Regulation 14 talks about working on or near live parts. And what that regulation basically wants us to do is ask questions as to why we need to be working live and are there suitable justifications for working live. We're not saying you can't work live. Anyone thinks you can't work live in the UK is talking rubbish, because you can. But you can only do it when you've got justifications for why you're doing it, and by putting suitable precautions in place to minimise and mitigate the risks. What about electrical machinery? Do we have safety interlock systems? Do we have a machinery isolation procedure? That'll be different from the electrical isolation procedure in a lot of cases. Right, this next one here, contractors. Let's get another elephant in the room out the way for you this morning. When we talk about managing electrical contractors, the reality is that in the UK, the way electrical contractors are specified, the main criteria is that they've got to be NIC, EIC approved. Yeah? Is that a fair point? The reality of that situation is that when you get an NIC, EIC approved contractor onto your site, it is most likely that the NIC will never ever have assessed the people who are actually turning up on your job. The NIC only assess on an annual basis one individual within an NIC, EIC approved contractor, and that's the qualified supervisor. That's the only person that they're making sure is competent. Not one of the electricians that work for them will go through a similar process. So if I was in your position and I was recruiting, employing electrical contractors, yeah, by all means, the NIC, EIC is a good thing to say as part of also looking at the actual competence level of the individuals who are going to be managing that work for you, the foreman, electrician, whatever it may be. The actual people doing the job, look at that. What about when we've got flammable gases, dusts, atmospheres, etc.? Have we got hazardous area classification drawings in place, zone drawings? Are we using appropriate tools? What about the inspection programme for hazardous areas equipment? Do we have staff that have specific training for working within hazardous areas, i.e. complex training? And it's not just complex training, it's complex training for that particular area that they're working in. There are 4 complex courses depending on the type of area. General petrochem, water industry, petrol filling stations and locations with dusts, 4 very different areas of complex qualification. About where we've got cables on site is the location drawings. Are we using locators? Do we have recognised safe digging practices being put into place? Overhead lines, have we got them? If so, where are they? Do we have location drawings? And again, have we got safe practices being employed? Again, you would be shocked, stunned how many incidents there are in the UK where somebody is working on some kind of mobile access equipment in and around overhead power lines, and an incident results from that. And if we've got HV, high voltage on site, clearly that means that we've got a lot of very unique requirements that need to be put in place on that. So, with all that in mind, that's a hell of a lot more that we need to be thinking about than going, let's get some pat testing and fixed wire testing done, isn't it? There's a lot more to it than that. Now, what do you actually need to do to comply? Lantai will not like me telling you this next bit, because you don't necessarily need to start doing pat testing and fixed wire testing of your equipment. There are other ways in which you can go about it rather than bringing a company in to actually physically carry out those services for you, because what you can choose to do to comply with Regulation 4.2 is you can put a proper planned preventative maintenance programme in place. Now we'll look at that in a minute, okay? But what you're going to see in a minute is that that's quite a difficult thing to put into place properly, which is why most organisations in the UK nowadays do actually go for bringing in a testing specialist who will look at things like mains analysis, thermal imaging, fixed wire inspection and testing, portable appliance inspection and testing. So let me go through these with you. Regulation 4.2, we looked at briefly before, talks about the requirement to maintain systems under your control. One of the ways you can choose to maintain systems, electrical systems under your control, is by putting in a proper planned preventative maintenance programme. To do that, you have to establish it and it must be documented, okay? There has to be copious amounts of evidence to support that programme and the implementation of it. And the key thing with this is that they have got to be regular and continual, okay? So the programme will talk about today we're going to be doing inspections on light fittings in a particular area, and then tomorrow we're going to be doing inspections on machinery in a particular area, and then next week we're going to be tightening connections on terminals on machinery in a particular area. It's regular and continual. Sadly, nowadays we don't have organisations that employ teams of electricians and engineers like they used to do. When we used to look at factories and hospitals and places like that, they used to employ teams of people on site all the time whose job it was to put PPM programmes in place. Sadly, we're in the, well, saying sadly, depends on which side of the coin you're on, but we're now in a position where we're in the era of subcontract. What we typically do now is we bring organisations in to do that. And if you're bringing in an electrical contractor to manage this type of programme, you're going to find that you've got them on site very, very regularly, and it's going to cost you a lot of money. And that's why people look about going about it in a different way. So let's start by looking at mains analysis. It's the first service that you can choose to implement for this. First of all, mains analysis. The beauty with it is that it can be done with the system energised. We get clients sometimes talking to us and they'll say, hey, fantastic, we've got a shutdown coming up in a few weeks, so we're going to do mains analysis and we're going to do some thermal imaging. What is the point of that? Because under shutdown condition, we're not getting a full view and an idea of exactly what the installation's telling us. So it's pointless doing that. The main thing with mains analysis is it allows us to do it when the system is fully energised in normal working operation. And what mains analysis allows us to do, in effect, is identify problems before they become an issue, before they start causing unexpected power loss, etc. So basically what that means is that we're able to make informed engineering decisions as to what we need to do and when we need to do it, i.e., well, we have got a shutdown coming up in a few months' time, we'll deal with these issues under that shutdown period. Now, the other thing with mains analysis is, if you get it done properly by a good company using the right test equipment, what it'll also do is it'll also enable you to see whether the supply that you've got is compliant with this standard here, EN 50160. Now let me read it for you just so I make sure I get the name right. 50160 is a European standard for the voltage characteristics of electricity supplied by public electricity networks, i.e., there is a standard that tells the supply authorities what level of quality the power supply should be going into the building as they supply it to you. Very important. And the reason it's important is because when we look at power supply and power supply quality, it's probably a phrase you've heard before bandied about, there are three parties in effect that can have an effect on power quality. So first of all, you've got the producer of the energy, the operator of the system. Clearly, if they're not supplying it, generating and supplying it in accordance with this standard. We've also got a document in the UK called the ESQCR, I'll get this right, Electricity Quality Continuity and Supply Regs, there you go. Say that when you've had a few bevies later 10 times. But we've got these pieces of legislation and standard to make sure that supply authorities are giving us our supplies in a particular way. Secondly, the manufacturer of electrical equipment can have an impact. Because what we look at now, and we talked about this briefly before, massive amounts of equipment that we're now connecting to electrical systems generates leakage currents. We'll look at another issue in a minute, but leakage currents naturally is a phenomenon that we see on things like laptops, air conditioning equipment. And if you're going into places like hospitals, sophisticated medical scanning equipment generates huge amounts of leakage currents. So clearly that can have an effect on the quality of our power supply, but that's happening because of the equipment we're connecting to it. And also the actual users of the system. We can have an effect by what we're plugging in to the sockets, by the way we're using it, etc., etc. Now, like I say, this standard here, if you're getting your mains analysis done correctly, your mains analysis will be telling you whether or not the supply coming in is as it should be. And clearly the implications of that are, and you guys will know as well as I do, supply authorities, certainly when you're looking at commercial tariffs, they're very quick to penalise you under certain circumstances, aren't they? Well, wouldn't it be nice if we were identifying problems that they were giving us where we could get back to them and say, well, hang on a minute, that's causing us issues. Now, apart from that, we asked the question, what will the mains analysis tell us? Well, it'll tell us all that. Which, if you're an electrical engineer, means everything, and if you're not, it doesn't mean a damn thing, probably. Key things to point out, it'll tell us what loading, what voltages we've got, it'll tell us things like power factor, it'll tell us things about harmonics. Now, I'll just touch on a couple of these with you. First of all, what energy am I using? Has anyone come across that standard before? A few of you? ISO 14001, for those of you who don't know, it's a management system standard for environmental management systems. Every management system standard on the planet, the big ethos of it is continual improvements, okay? So clearly, when we look at an organisation and we're assessing what our impacts on the environment are, our environmental aspects, one of the main ones for every business on the planet is that they use electricity, they're using energy. So clearly what 14001 is saying is that we need to reduce our energy uses where possible. Carrying out mains analysis will allow us to establish what the benchmark is, what we're using now. We then put a programme in place for the reduction of it. Mains analysis will tell us where we've got to following that programme. It'll tell us about efficiency of our electrical installation. And when we talk about efficiency, specifically we're looking at whether or not we've got power factor issues within our electrical installations. And again, for those of you who aren't really aware of what that is, certain types of electrical equipment actually need two types of power to make them work. So first of all, you've got what we call actual power. Does what it says on the tin. It's the actual power that that piece of equipment needs to make it actually physically work. But what we find when we've got poor power factor correction issues within our electrical installations, that equipment also needs what we call reactive power to make it work. So to put it another way, we're using two lots of energy, one of which, if we was to improve our power factor, we wouldn't need to use, i.e. we're spending more than what we need to be spending. That's another thing that mains analysis will do for us. So in effect, it's going to save you money. That's an easy sell, isn't it? If you're responsible for the maintenance of electrical systems and you're trying to convince bosses what to be spending the money on, well, you can start talking to them about how it will save them. Everyone's a winner, aren't they? Now, what else is mains analysis going to tell you? Mains analysis is going to tell you about harmonics. And for those who don't know harmonics, I've put as easy to understand statements on the top of the screen here. Harmonics are currents or voltages which frequency is a whole multiple of the fundamental frequency, okay? Which basically means, in the UK, we distribute electrical energy, generate and distribute electrical energy at 50 hertz, RMS. And that's what a 50 hertz waveform would look like on a graph. When we've got harmonics issues within electrical installations, and just as an example, we'll look at the tripling band, the third harmonic, what that means is that our frequency is multiplied by that number. So 3 times 50, 150 hertz. 150 hertz would look like that on a graph. But the problem we've got is when those frequencies start to be added together, which is what we get with harmonics distortion issues, that is the net result of what our graph would look like. Now, I don't know if anyone did shaky jakies when you were a kid. Do you remember them? You had to get the coat hanger around the thing, yeah? Remember them? It doesn't take a genius to work out. That one's easier to do than that one, doesn't it? Yeah? Bit of a tangent to know, but you get the point I'm making. Clearly, that's going to cause us issues, and it's going to cause us difficulties. And I suppose the key question is, that's all well and good, Dave. What do harmonics actually do? Well, I'll tell you what they do. What they do is they cause a number of problems in electrical installations. First of all, we get what's called the skinning effect. Harmonic distortion, harmonics issues start to generate neutral currents, currents that the neutral conductors were not designed to cope with. And because these neutral conductors are carrying currents they're not designed to cope with, what happens to the conductor is it starts to get et away from the outside going in. It's called a skinning effect. So what's now happening is our conductor is reducing in size because it's carrying currents it shouldn't be carrying. The more it reduces in size, the less capable it is of carrying the currents that's going through it that it shouldn't be carrying. You can see how the knock-on effect of this, can't you? Because very, very quickly, the net result of that is that it causes fires. And again, this is a very common problem that we've got in the modern built environments. Very, very common. When we look at the types of equipment that generate harmonic distortion, harmonics issues, well, funnily enough, it's all the same types of equipment that we were talking about before for leakage current issues. And when you look at the screen here, you're looking and probably thinking, wow, that's virtually everything we've now got in our offices, in our commercial environments, in our retail environments, in our... You get the picture, don't you? It's a very, very common issue now that we're up against. Right, secondly, you can look at getting thermal imaging carried out. Again, the beauty with thermal imaging is it allows you to carry out the inspections with the system operational, with the system under full load. As with the mains analysis, what it's helping you to do is identify problems before they become catastrophic, before they cause unexpected power loss. Net result, again, we're back to making informed engineering decisions, and that's going to save you valuable downtime, and therefore it's going to save money. In effect, what does it do? Well, it measures the temperature of the equipment that you're physically inspecting. And when we look at, I don't know if you can all see them, are they pretty clear for everybody? When we look at the two thermal images that we've got on the screen, the one on the left-hand side here, this is a distribution board. There's your buzz bars running through the middle. All these are our circuit breakers running down either side of the board. As you can see, one of the circuit breakers is getting very warm. Both the terminals on the buzz bar, the terminal where the cable is, and the cable itself. We've also got a cable there running very warm. Clearly that's still on. It's still active. But it doesn't take a genius to work out it's not going to be staying live for much longer. That device is going to activate sooner or later. Prime example of what thermal imaging is there to do. The image on the right, ladies and gents, is another distribution board, different site. And what you've got, there's the isolator at the bottom of the distribution board. Again, buzz bars running up. There's our circuit breakers. These 4 cables you will see going in are our 3 phases and our neutral going into the isolator. That very warm cable on the right is a neutral conductor that is suffering from harmonic distortion issues. That's the effect that harmonics can have. Okay? Very, very real this is, ladies and gents, very real. But again, thermal imaging, what happened on this particular site, thermal imaging was done first. That image led us to believe there were harmonic distortion issues. We recommended mains analysis was carried out. That was able to give us a much more in-depth understanding of what the problems were and where they were. When you get mains analysis carried out, what you're looking for is something similar to this in terms of a report. So what we want to be seeing is an actual photograph of what's been inspected, what's been imaged. There's the thermal image itself, discusses the temperature rises, etc. And what you should also be looking for is a nice little comment at the bottom that tells us what the problem is and what should be done in terms of a recommendation for dealing with that problem. Okay. We now move on to fixed electrical installation inspection and testing. Some people know it as fixed wire testing. And in effect, when we get fixed wire testing carried out, what we are looking for at the end of it is an EICR, an electrical installation condition report. It used to be a PIR, periodic inspection report. That's what it's called now. And if you want to ask the question why we need to do it, well, BS 7671, the wiring regs, gives us these statements here. And it tells us why we need to be doing it, mainly because we don't want people, livestock getting hurt, getting injured. But more importantly, and again, most of you are probably here in addition for the update seminar, which is the second part of this morning. But the wiring regulations are updated periodically for 2 main reasons, ladies and gents. First of all, to take into account safety improvements that need to be made. So I'm back to that statement from before. We are a reactive nation. Things go wrong, we try to stop them happening again. That's the first reason the wiring regs are updated. The second reason that they are updated is because we are now connecting equipment to our electrical installations that we weren't connecting before. Think about 20 odd years ago. We weren't using IT equipment anywhere near the way in which we're using it now. So harmonics issues, leakage issues were nowhere near at the forefront of our minds like they are nowadays and like they should be nowadays. So these are a number of the reasons why we need to be inspecting and testing our installations so that we can assess them against current standards and assess them for safety. What you should be getting when you get fixed wire testing carried out is you should first and foremost be getting an inspection of the accessories and the equipment. Now, here's another misconception we're going to get out the way for you this morning. What you will hear in this industry from certain sections of the industry, you will not read it in authoritative guidance, I might add, is you will hear 10%. 10% will do you. And we refer to them as the 10% will do you mate brigade, because there's a lot of these out there. Yeah, do 10% inspection and testing, you'll be fine. You will not find any reference to 10% inspection and testing in any guidance or in the wiring regulations. The only reference to 10% that you will find anywhere in IET's documentation is in Guidance Note 3, where it refers specifically to the inspection of accessories and equipment. And what it says is that as a bare minimum, you should inspect a 10% sample of equipment and accessories on every circuit that you are inspecting and testing. Okay? And you can see how big a difference that is there. We'll look at frequencies in a minute and it'll hit home a little bit more to you. So yeah, as a minimum, we're looking for a 10% sample inspection of accessories and equipment on circuits. However, if that initial 10% leads us to have a concern, then we have to increase that sample and we have to do more and more until we're able to make an engineering decision as to whether there is or there is not a problem or a non-compliance on that part of the system. What we're also looking for is testing of circuits. And the reason we do testing of circuits is because we want to identify faults. So very quickly, a couple of examples. We carry out insulation resistance testing because we want to see what the condition is of the insulation around conductors. We want to see if there's deterioration of the electrical installation. We carry out earth fault loop impedance testing because we want to make sure that the protective device for that circuit is going to activate in the case of a fault. So clearly these are important, but you speak to the likes of Anthony and myself, and what we will normally tell you is that if you're looking for a percentage importance of these two, the importance of the inspection is 70% compared to 30% for the testing, because the inspection will always tell you more about that installation than the actual testing of it, okay? What should you be getting? Well, we said a minute ago you should be looking for an EICR, Electrical Installation Condition Report, and what that should be doing, or what it should have, is it should have a schedule of inspection, i.e. what are the results of the inspection and what inspection was carried out. It should have a schedule of testing that was carried out for each and every board in which it was carried out on and what the results of that testing are. And most importantly, it should have a list of observations. And the reason it needs a list of observations is because these are the items that are being identified as items requiring rectification for you to maintain this electrical system, okay? When we look at the observations, they should be coded. There are 3 codes that they can potentially, at this moment in time, there are 3 codes that you can potentially be given to each observation. First of all, a code C1 means that there is danger present. There is a risk of injury. Immediate remedial action is required. Not tomorrow, not next week, now, okay? Classic example is wherever we've got access to exposed live parts. Secondly, a code C2 means that it's potentially dangerous. Urgent remedial action is required. Not next month, not next week, not next month, not in the next few weeks, next week. This needs to be done sooner rather than later. And then we look at a code C3, means that improvement is recommended. Now, we've got 2 examples for the C2 and the C3. Both of them seem to be, the first one on the screen regarding RCD protection for portable equipment that may be used outdoors. Clearly what we're saying there is even though this is relatively new requirements, even if we've got a very old electrical installation, this is a relatively new requirement, what we're doing in effect is we are taking electrical equipment outside, i.e. outside the equipotential zone where we haven't got our protective measures fully in place because we're outside the equipotential zone. That's why it wants it to be an RCD. Your difference with the C2s and the C3s is that C3s are more there for looking at issues that they need improving, but also issues that are being highlighted by new editions of the wiring regulations, okay? Because we're taking into account safety improvements that need to be made. So the example here, a very quick one, socket outlet mounted in such a position as to result in potential damage to the socket and or the flexible plug, i.e. it's too close to a work surface. But many of the things that Anthony's going to talk to you about later in terms of the changes to the wiring regs, if you were identifying them as part of an electrical installation inspection and test, they would be C3s. Now, I'm not going to steal Anthony's thunder. He's going to talk to you in this about much more detail about this later on. But at the moment, if we identify a C1, C2, C3, what we may do is put a further investigation requirement next to it, because basically what we're saying is, well, we don't know, but further investigation needs to be done to allow us to make an informed engineering decision. Like I say, Anthony will tell you about the slight changes that we've got with this later. So, how often should you be carrying out electrical installation inspection and testing? Right, first of all, there is some guidance on this, and the key word is guidance, by the way. And the guidance is given to us in this document here, Guidance Note 3. There is a table in there. And the table in Guidance Note 3 gives us the maximum, that's the key word again, maximum suggested frequencies between inspection and testing of the different types of electrical installations. Okay? However, it frightens me how many clients that we go to speak to or that you hear of where they're dictating to contractors what should be on the frequency. Well, why have you put 3 years? It says in this document, it says in Guidance Note 3, it should be every 5 years. Why have you put 3? Well, the reason an engineer might put 3 is because what they've seen is deterioration in the electrical installation. They're concerned that the electrical installation isn't going to last another 5 years, or that there needs to be more regular checks because the condition of it is not what it was when it was first put in place. In addition, we might have special locations within our electrical system. The wiring regulations defines a special location as an area of increased shock risk. So we're looking at things like bath and shower locations, swimming pools, saunas, marinas, things like that. So there's an increased shock risk. That is a reason why we may decrease the frequency between the inspection and testing. Now, to give you sort of a rough guide on how you can go about doing this and managing budgets, etc., what I've done is I've just put a very basic layout of a building. In this case, it's a prison. We've got 4 wings and a set of workshops on it. And when we look at Guidance Note 3 and we look at a location similar to this, what it'll tell us is that the maximum frequency is every 5 years. Okay, the maximum, every 5 years. So one of the things that we could choose to do is we could choose to do 20% of the installation every year over that 5-year period. So clearly, we'll do the A wing this year, B wing next year, C wing, D wing, and then the workshops get done in 2019, okay? That's one way of going about complying. You will notice the 10% will do your mate brigade. Doesn't work here, does it? Because if we're only doing 10%, we're only actually assessing 50% of that installation in the period of time we should be assessing the whole thing, okay? So we've got to be very careful here. Now, a word of warning to the wise. If you've never embarked upon an inspection and testing program before, and it's the first year you're going to do it, this ain't going to wash. This ain't going to work, because the first year what you need to do is 100%, and then you can set up your program for the rolling maintenance of it. And there's a simple reason for that. If we don't do that, it's going to be 2019 before we start finding key issues in the workshops that need our attention and need to be maintained. That's why you need to be doing 100% first and then kicking off your program if you choose to go down this route. Now, again, it's unbelievable sometimes that you go to some companies and they think, well, we've had it done, we've had the fixed wire testing done, that's us all compliant. No, it isn't. Because if that fixed wire testing has highlighted a list of observations, or I'll put it another way again, a list of items requiring attention to maintain the electrical system, then clearly what you need to start doing is rectifying. I don't like the term remedial, but it's a common term in the industry nowadays. You need to start rectifying and remedying those particular issues. Clearly, C1s, C2s, they need your attention. They need it pretty soon, okay? When we look at C3s, you can make a decision as to whether you do or whether you don't want to rectify that, okay? But I'm going to say to you again, most C3s will be generated and raised because it's identifying a non-compliance with the current version of the wiring regulations. These standards are updated to take into account safety improvements that need to be made, okay? But we're still playing with budgets. So once you've decided what you're going to get done, you're going to get somebody in to do it. What you are looking for them to do once they have rectified it is provide you with some kind of documentation, some kind of evidence that suggests that they've done that for you. And the documentation they should be giving you, and when I say should because the wiring regulations very clearly says if an alteration or an addition to an electrical installation has been carried out, a minor works certificate must be issued. Very clear, word for word virtually. And what the wiring regs also says, virtually word for word, if electrical installation work involves the addition of a new circuit, an electrical installation certificate, otherwise known as a completion certificate, must be issued. Okay? So here's another misconception we're going to get out of the way today. Some clients I go to, or you hear of, insist, once the rectification work's been carried out, I want my EICR's overall assessments changed from unsatisfactory to satisfactory. Okay? If you ask a contractor to do that, you are doing the wrong thing and you are forcing the contractor to do the wrong thing. If you're a contractor and you do that, you're doing the wrong thing. I'll stress this because it's so often we see this. If you want to demonstrate compliance with Regulation 4.2, that you've maintained this system under your control, you do that by saying, there's a copy of the EICR and there's the copies of the minor works and or completion certificates. Them together show us that we are maintaining this electrical system. That's how we evidence compliance with Reg 4.2 if you go down this route. Okay? Very important, that. Right, last but not least, and there's a good reason this is last, but last but not least, portable appliance testing. Again, we call it PAT testing. Technically, that's the wrong thing to call it. It's actually the in-service inspection and testing of electrical equipment. And the reason we call it that is because electrical equipment isn't all portable. Okay? There is a standard for this. There's the standard. It's drafted by the IET, Code of Practice for the In-Service Inspection and Testing of Electrical Equipment. And what this standard does for us is it first of all breaks down the different types of electrical equipment and it categorises them. And it attempts to give us some guidance on how often they should be inspected and tested. However, you've got to be very careful with this because when it was the third edition of this Code of Practice, there was a table there, and the table did give us the maximum suggested frequencies. Okay? When the fourth edition of this standard came out a couple of years ago, what it now does, okay, it doesn't say follow that table for the frequencies. What it now says is that the frequencies should be determined following a documented risk assessment of the various types of equipment. Now, if you guys have got budget for electrical safety, what I would suggest to you this morning is that you start looking at how you can free up from one area to put it into the more important areas. And this is why PAT testing is last. Is it the most important service? No. Because we can have the safest appliance in the world, but if we plug it into a socket with no earth, it's neither use nor ornament to us, is it? Okay? So, this is a way in which you may be able to free up budget to put into more important areas of electrical safety assessing. First of all, Code of Practice breaks down the different types of equipment. Portable. Classic example of that would be a lawnmower. Movable transportable, washing machines or dishwashers. Handheld equipment, hairdryer, something like that, etc., etc. You can see the different types of equipment. And then what we also look at is, well, what's it used for? Okay? So a lot of sites that we go to, or a lot of clients that we speak to, they're doing PAT testing on everything every year. Now, if you look at something like IT equipment, we've got a PC tower under a desk. It was put under that desk 4 years ago. Desk's never been moved. The cable and the flex to the socket is all behind that desk. What is the risk of damage to that piece of equipment, ladies and gents? It's minimal, isn't it? So why would we need to test and inspect that equipment every year? We don't. Or it's highly unlikely that we do. However, conversely speaking, if we've got equipment that's being used on a construction site or in workshops, clearly it's going to be more susceptible to damage than if it was being used in other types of locations. So these are all the factors that we need to be looking at that allows us to determine what the frequencies are for our inspection and testing of electrical equipment. What's the competence level for this? I'll get another misconception out of the way for you. A lot of companies get it done by the local electrical contractor. And the local electrical contractor sends one of the people who work for them who doesn't really want to be doing PAT testing. Okay? And I'll tell you this now before we go any further. Just because somebody's a qualified electrician and they went to college for years and years doing all the electrical quals and they come out the time and they've got these certificates, I will tell you now that it is highly unlikely that at any stage during that apprenticeship period they went through training for portable appliance testing in the Code of Practice. Very, very unlikely. It is a semi-skilled role, let's not get away from that. But that semi-skilled role needs to involve training in the requirements of the code of practice and how to actually inspect and test electrical equipment. And you'll have seen this happen before, by the way. They walk in, they plug it in, they press a couple of buttons, the test takes a minute. That is not portable appliance testing, okay? What should you get? Well, the minimum you should be looking for is a label on it. Has it passed, has it failed? Okay? But the better companies out there, what they will also be producing following carrying out PAT testing, for a better phrase, is they will be giving you, in effect, results of the inspection and testing, which will form the basis of an asset register for you. Okay? And again, I'm going to emphasise this. Is this the most important service? No, it is not. We're not saying don't do it. What we're saying is have a look at the other things and ask the question, could we be doing them before we're doing this? That will be a sensible approach. So remember, the more of that lot you do, the lower your risk is going to be, the more compliant you're going to be. Simple as that. This is something a lot of companies miss out on. In the vast majority of organisations, the people or the person who negotiates the insurance premiums on an annual basis is usually an FD or an MD, isn't it? Is that a fair point? In a lot of cases. Very rarely would that person be aware of all the various maintenance activities that have been carried out that allows the risk to be lower in effect. So are they telling the underwriters that? Because if they are, underwriters should be considering it and hopefully giving you lower premiums as a result. We'll look back at the energy efficiency issues. If you're identifying them and rectifying them, clearly you're saving money on your energy costs. Back to selecting your contractor carefully. Don't just go for NIC. Also look at what else. Are they experienced in this? Are they qualified? Are the people competent who are actually doing the work? And one more time, and I will harp on this, beware the 10% will do your brigade. Because as we saw before, it won't. Simple as that. Last but not least, I suppose there is a little bit of good news in all of this because the electricity at work regs, Reg 29, does give us what is a basic human right really, I suppose. Doesn't quite seem to apply to us in Liverpool for some reason, but we are innocent, are we not, until we are proven guilty. Electricity at work in the UK is no different. Reg 29 reinforces that. What it says is that in any proceedings for an offence consisting of a contravention of regulations, notice, by the way, most of the regs we've looked at today are in that list. It shall be a defence for any person to prove that you took all reasonable steps and exercised all due diligence to avoid the commission of that offence. So in short, ladies and gents, if you're making sure that you've got all your adequate documentation that demonstrates and evidences how you're complying with your legal requirements, when this happens, and touch wood, it never does to anyone in this room, by the way, but if and when it happens, you'll be okay because you'll be able to demonstrate that you've done what you should.